Hey, I'm Dapper Dan, and welcome back to Builder's Journal. I say welcome back because in case you missed the first episode, this is episode 2 of our journey building with Giza and ZKML. In case you don't know about anything about Giza or ZKML, you're in luck. Check out the first episode where we explore and explain both of those things. For this episode, we're going to build the data set that we will use to train our machine learning model. Data, as you might know, is the core of doing anything with AI or ML. You need to go places. It's like the coffee to the developer, or the protein to the bodybuilder, or maybe even the sparkling water to the European. Man, I love that stuff. But I'm sure you get the point now. Now, blockchains produce a healthy amount of data on their own. Transactions contain a lot of data that might be important on making predictions, whether it's transaction data, so who's getting what, the amount being sent. But getting all that data in a good way for machine learning models can be tricky. You used to have to go out and hunt for data yourself, but fortunately there are a few providers out there that make this a much more easy experience. And we're going to be using some of them today. If you remember from the last episode, we are building a Farcaster bot detection model. Hopefully we will have a model at the end that can take a Farcaster ID and give it a prediction if it's a bot or not. So naturally, we're going to need some Farcaster data. To determine what data we need though, I went around exploring the internet and seeing what others have done in the space in terms of social media bot detection. From there, I found the Tweetbot 20 and Tweetbot 22 papers. Pro tip, if you're looking for inspiration, you can always find them in the PDFs. In these papers, they created a graph neural network. In these models, we have nodes, which represent social media accounts, and edges, which represents the relationship between those accounts. Based on the relationships, we can make predictions on that account, whether that might be a bot or maybe it's just a great account that person should be able to follow. While these papers don't share all the complete data sets, they did give a sample of what they actually use. So why I haven't actually settled on the model type just yet, we're going to use these as some inspiration for the data that we might need for this application or this model. That's enough talk though. Let's go hunting for some data. To the code. Like I said, I'm going to start with the inspiration of this Tweetbot in terms of what they actually used in this paper. And they presented this JSON file that I'm taking a look at now. It's got some interesting things, right? So it's got the name, the screen name, so this is Shack. I'm not sure if this is actually the real Shack, but it's one of Shack's. Description, which is important, right? Maybe how they describe them. The URL, which could be useful. Favorite counts is also another one. Friend counts and follow counts is actually really important too. And then they got these tweets, which I think is going to be something we also will need to have for this data set in terms of all the casts that the user has sent and what it contains. A lot of tweets, I think it's like almost 100 or something like that. Then what I really want is also getting the follower counts, what they call here neighbors. So this one's missing, but if I go to another profile, Jennifer Fishpaw, shout out to Jen here. Then you can see this neighbors, right? So it's got following and followers, but no followers here. But this is also really important when we're talking about these graph neural networks, because the neighbors is who they're following and who's following them. If we want to build a graph for that, that's going to be kind of important to build that and see the connections and relationships. Again, I'm not sure if we're going to use a graph neural network here. We might use something like a decision tree, but this is going to give us inspiration then on what I want this data set to look like. So the first stop is actually using the Giza embedded data sets that are included with working with Giza. So let's see if I go to this notebook here. So off the top, this isn't going to be like how to be the best data scientist 101. This is going to be me trying to build this model out, and you're going to be watching this as I go. So some kind of funky things here, maybe not the best data science practices in the world, but hey, we're going to get there together. So first thing I did here was just import these Giza datasets. Also to import some other required packages within Python. And then I'm going to load in what is the Farcaster cast dataset. And what they did was like pull in, I think like 2 days or 3 days worth of Farcaster data, captured it all. It was in like January or something like that, and put it in this dataset, which is actually quite big and really useful for, I think, for our purposes of what we're building here. So what you'll see, I have this datasets load, and then this is actually good practice for a data scientist. I want to look at the dataset, so I use this df head. So this is like getting the first 5 of that dataset just to see what's in there. And yeah, you can see here, so it has the hash, which is kind of the transaction, if you will, on the blockchain. But what I'm most interested in here is the text, so what is actually being sent to, what's actually in the cast, so we can kind of determine that, as well as the FID, so the Farcaster ID of that particular user. So I want to make an attachment. If you look at the Tweebot dataset, right, they had the data as well as what was being cast there. What we're missing and what we're going to explore later on is like, okay, I have this Farcaster ID and what they send in this 3-day time period, but I also need to know exactly who's this ID and who's following them. So I'm going to leave it at that. So this is a really good start, and I kind of explored a little bit more about what's in this data set. So for instance, I took in like the unique count of that, and I've gotten, that was like, 110,000 unique Farcaster IDs there. So it's a pretty good representation maybe of at least Farcaster at that time. And also the number of rows. So this is the number of entries within this data set, pulled that in as well. You can see that's like, what is that? Ooh, that's a big number. 5 million almost. So really big chunk of data set. And then I also did some things. I'm just checking random IDs within that data set, whether or not they exist. Just to pull that in there so you can see, for instance, this Farcaster ID is true. So that means it's in the data set. And also took some things like taking 20 random ones there. So now that I have a large amount of data in terms of Farcaster IDs as well as the cast, I also want to get the relationships between different Farcaster IDs. And for that, the first place I actually started was Airstack. And Airstack, give big shout outs to Alex and the team there at Airstack. Hope I didn't got the wrong name. That would be really embarrassing. But I'll put the Twitter as well. They were super helpful in helping me making sure I get the right query, as well as the community. I reached out to see what services were out there. Like I said, getting data sets from the blockchain now or different blockchains has become easier. So explore all these services. There's Airstack. We're going to use also this other one. So there's a lot of things out there that you can start using. So with Airstack, what I wanted to do was take in essentially all the Farcaster IDs that are in this data set and give it to Airstack to give me the follower accounts, who they're following, and who's following them. And with the Tweebot data set, it was like 10 random ones. So I just said, great, let me just limit this to 10. So what you'll see here in this query, if I just scroll up here, is that we do actually have this limit to 10. We're going to limit it, and then we're also going to take in the profile name, the bio, and if this is a Farcaster power user or not. Maybe not necessarily going to be useful for the model per se, because I think that definition of power user changes quite often. But that's going to be something that we're going to have there. I did some testing as well just to pull in the variables. So in this case, it's just one Farcaster ID, but obviously I need a lot of them. So I've removed my authorization here, so you're not going to take my accounts. But you can set this up relatively quickly. And you saw the amount of Farcaster IDs that I had there in this data set. So that means I'm going to be making a lot of requests here. I think there's probably a better way to bulk this, but this is the query that I'm going to use. Also, big shout out to Farcaster because, Airstack, because I'm making a lot of requests here, and I'm on a plan that gave me some free credits because I had Farcaster ID, I think I had Lens and things like that. So this is actually a good model in terms of rewarding people for on-chain activity or on-chain accounts. So I had about like 2 million queries or something like that free, and I don't think I wouldn't be able to do this project without that setup. So big shout out to Airstack on that setup as well. So we're gonna take in, I pulled in some of the Farcaster IDs that I got from the data set, which you'll see here, and then I also just did a tail, so this is kind of like opposite of head, but just bringing it in, and then making a request, so a post request here with those variables, so the variables being what we have or in terms of Farcaster IDs, and then you could see a basic, just a test of this, which will bring in both the followers, the addresses there, the profile bios, which could be important, and then whether it's a Farcaster power user. So like I said, then I wanted to make this like pretty big request here in terms of getting all of the Farcaster IDs that are in that Giza data set. And this one, it took around 17 minutes to complete. And you can see, unfortunately, that kind of kicked me off after a while. Well, disconnected there. I probably could have done something really smart here on timing it out and making sure that I complete all of these, get all of these IDs in. But I wanted to go ahead and just see how many things are actually pulled in. So first I just checked that I actually got something. So just printing out the results. And then I wanted to see, so I did a check. So I created the CSV of all the unique FIDs that are in the Giza data set. Like I said, it's 110,000, quite a lot. And then I wanted to see like how many did I actually get within this data set. So I created a data frame called followers, which you see here, and then just wanted to pull in just to see like, okay, I got timed out. How many did I get in? And I got like about 1,733, so almost 2,000-ish. Farcaster IDs made in the request. Now this might not be enough for this project, but like I said, this is going to be very much a proof of concept just to see what we can do with Giza, ZKML, and Farcaster data. So I'm going to stop there in terms of the data. I probably could do something really smart here and then find out where it stopped at and then start over again. And I might, in a later episode, have to do that. But hey, we're building this plane as we go. So what I did instead, I created this other data frame, which is the neighbors data frame, and I just cut it. So basically I said, once you get to 1,733, just stop there. And then we're going to have now a data frame with all of the neighbors, so the followers, the following count, as well as the ones that we actually pulled in from the Giza dataset. So I kind of made the Giza dataset smaller, in compact for what we got from the Airstack. So what that actually looks like, let's see, where are we? I think it's the neighbors. So this is like the JSON that I got back. So now you can see here, which is really nice to cleaned up here, is that I have the Farcaster ID, a list of at least 10 followers. If they don't have 10 followers, then obviously I can't make up followers, sorry. And then the following as well. So we have a 10 here, and that's a pretty good representation of the relationships. And hopefully there'll be a good enough connections that we can build either a graph between those relationships or maybe a different type of model. Now, I got the data from the Farcaster IDs and the cast that they have and the followers. But I also want to get information on not only just the Farcaster ID, but what their bio is, like what they describe themselves. This could be important, as well as the actual username or of the Farcaster ID. So I just have IDs, which is good, but maybe it would be nicer to actually see cleaned up names. So for that, I used Neynar, not Neymar, the Brazilian football, but Neynar, to do this. So if I go to Neynar, and this, I've split this up into 3 different Jupyter notebooks. So if you do look at the GitHub, you can check that out. And with this one, basically I take took the neighbor's JSON file that was has all the Farcaster IDs and basically looped over that. And I used this, I'm not sure, they're probably gonna hate me for this, but within their docs, they had this version 1, which I thought was a pretty good endpoint to get all of this information. And then they also included this Neynar API docs key for that. I used it, I'm sorry, but I did make sure to time this out in this case. So, because the first time I did it, I received, you can only do like, I think 15 requests in 60 seconds or something like that. And obviously I have way more requests to do. So I did time this out a little bit. So every 4 seconds it makes a new request. So just spacing those out. So hopefully it didn't break anything on their side. It took me some time, so 85 minutes to get all of this data collected. But hey, that's the machine learning work. And then what I had to do was also split this. So I have this neighbors 1 and neighbors 2. Again, let me know in the chat or in the comments, tweets, or whatever, if you think there's a better way to do this. I'm sure there is. I probably could have done this as well with Airstack, but I'd like to diversify, make sure that we get the right data. And then lastly, I pulled this in and saved it into user profiles JSON. So if we look at that now, what we have is awesome because we have the Farcaster ID. So that's what we've been using throughout this whole thing. A custody address, which I need to actually look at to see what that actually means in Farcaster world. Obviously, that's kind of the address that's maybe attached to that, the wallet address that's attached to creating it. And then the username, which is great. Profile picture, if I need that, why not? Inactive, the active status, which is great. And then also the power badge, which I think I got also from Airstack as well. Then let's see if I can have a good one. You can see the follower count, just like in the Tweetbot data set. So also going to be really good when we're trying to make predictions. All right, maybe bots have like tons of follower accounts following people, but very little following. That's maybe a assumption I'm making, but we'll get to that later on. And then even like this ETH addresses that are attached. So maybe even verifying that later on will be interesting. So now that I have like basically 3 different JSON files, I have a JSON file that has the neighbors based on the Farcaster ID, so all of the relationships. Then I have this JSON file that has all of the user profiles, and basically a JSON file that has all the cast, which I think I made here. Right, so this has Farcaster ID and then cast, this is a cast from one account, the Rake Fun Quiet, Gulch Woolly Open. So really thrilling content, as you can tell. And then Farcaster ID, this one has a lot more cast. Also see this null, which I have to probably look into, like, can you send a cast but nothing? But then you can also see quite a lot of the dgen, address accounts posted, I guess. So you see a lot of this thrilling content coming from this account as well, or at least some actions being made. So good to know. So basically I have these 3 JSONs, this one, the neighbors, and then the cast. So I need to just basically pull all this together, and it's going to look like what we have for the Tweetbot data set. In order to do that, what I did was basically, let's see, go back to the Giza data sets. I created 3 dictionaries of this. So loaded all the JSON files. So these 3 JSON files there, looped over each of them, finding the Farcaster ID and then combining them based on the Farcaster ID. So if we look at the data set, and this is the big reveal, we have now, and I put these file 1, file 2 just to keep it my mind sanity here. We have the Farcaster ID, right? 355637. It's got the custody address, all of the data there. I can see the follower accounts and the following account, which is accurate. So I can also test this out. So in this case, right, followers is 1 follower and 2 following. So I have those Farcaster IDs, and as well as the amazing cast that this account has sent, which is Rake Fun Quiet Gulch Woolly Open. So now that we have that big reveal of the data set, that's all we need to at least start to build a machine learning model. Again, maybe we'll need to add more data. Maybe we'll need to clean this up a little bit and pull out some important parameters. But That's going to be done in the next episode. So I'll see you there where we will build and train our first model.